Hello everyone. So in this session we'll see another problem on area by double integration for Cartesian coordinates. So let's say the question is like this, which is find the area bounded by the lines, which is like the curves y equal to sin x, y equal to cos x and x equal to 0. Now we can see the first two curves are trigonometric. We can draw the graph for that, and x equal to 0 is a line which is y-axis. So let us try to understand the graph, the region bounded, the point of intersection. So we can see that this is x equal to 0, this is y equal to cos x, and the other one is y equal to sin x. So the region bounded by these three curves is this one. And now we can look for the point of intersection. So one of the point is this one, the other one is this, and the third one is this. So with the condition of x equal to 0, purple curve, that is y equal to sin x, for x equal to 0, y becomes sin 0, which is 0. So this point is actually 0 comma 0. The other one is the intersection of x equal to 0 and y equal to cos x. So for x equal to 0, y cos 0 will be 1. So this becomes 0 comma 1. The other point of intersection is between cos x and sin x. So this is possible when sin x is becoming equal to cos x, that too which is happening in the first quadrant. Of course, there could be more point of intersection. So with this, this is possible when you can either say that tan x is 1. So x becomes pi by 4. This will give the limit for x. So one of the limit x equal to pi by 4, the other one is x equal to 0. Now if we try to understand or divide the area into vertical strips, so dividing the region into vertical strips, let's say with width dx. So for this region, let's say this is our vertical strip. We can see that the point, starting point, let's say is P, the end point is Q. So the starting point P lies on y equal to sin x, and the end point Q lies on y equal to cos x. So with this, we can say that y varies from P to Q, which is again P is on sin x. So sin x to cos x. And for x varies from, just now we saw that, from 0 to pi by 4. We cannot keep 45 degree because we are talking in numbers, not in degrees. So we need to put the value in radians. So 45 degree, or otherwise in radian it is pi by 4. So we'll use pi by 4 here. Okay. So with the limits here, now the area required will be given as double integration x equal to 0 to pi by 4 and y sin x to cos x dy dx. That's it. So first of all, integrating in terms of y, putting the limits, then whatever result comes, integrating in terms of x, putting the limits, and that's it. That will be the area for our region bounded. So integrating in terms of y, so dy will give us y. So y with the limits cos x, sin x, and this whole thing gets integrated in terms of x equal to 0 to pi by 4. Okay, so the limits for y, cos x minus sin x, this needs to get integrated in terms of x with the limit 0 to pi by 4. So integration of cos x is sin x minus sin x is cos x. Sin pi by 4 plus cos pi by 4 minus sine 0 plus cos 0. So this is 1 by root 2 plus 1 by root 2 minus sine 0 is 0 and minus 1. So 1 by root 2 plus 1 by root 2 becomes root 2 minus 1. So this is the area we're looking for. So for the region enclosed here by the three curves, the area is root 2 minus 1. I hope this is clear. Thank you.